Hi children, welcome back. Last class we have seen that metallurgical processes. Today we will continue with that different stages. I think the word metallurgy is clear to you. For after collecting a metal ore from the earth, for separation of the metal from the ore involved three different stages, and all the three stages together it is known as metallurgy. And the second stage is the extraction of the metal, that depends upon the reactivity of the metals. Okay. Now we can see that three different stages of metallurgy in detail. First stage is stage 1, and in that stage 1 we can see the removal of earthly impurities. Normally we are getting that ore from earth crust, that you know, isn't it? And at that time sand, soil, small pieces of stones, all these will be associated with that ore. So earthly impurities will be associated with the ore, and that earthly impurities are known as gangue. So in the first stage, after getting the ore from earth, we are removing the earth impurities associated physically, we are removing the impurities associated with it, and by adopting different techniques we are removing the impurities associated with it, and that is during in the first stage. And the earthly impurities associated with this ore is known as gangue. Gangue is the earthly impurities associated with the ore. Okay. So we have to separate that impurities from that ore. After that only we can separate the metal from the compound. For that, different physical methods are adopted depending upon the nature of the ore and nature of the gangue particles. Gangue is the earthly impurities associated with the ore. So depending upon the nature of the gangue as well as nature of the ore particle, we are adopting different techniques for the removal of these impurities. For example, there are different methods we can use there for the separation. Magnetic separation is there. Magnetic separation, and then magnetic separation is there. Then next we can use another method. Gravity separation is there. Gravity separation is the froth flotation method is the so depending upon the nature of impurities or gangue present in that ore or the nature of ore, depending upon both their properties, we are selecting different techniques for the separation, removal of impurities, and this removal of impurities is known as enrichment of the ore or enrichment of the ore. Enrichment of the ore, or otherwise it is known as concentration of the ore. Concentration of ore. So for the stage 1 we are calling that stage as enrichment of the ore or concentration of the ore. Two terms we can use, either we can use the enrichment of the ore or we can use the concentration of ore. For the enrichment of ore, that is known as removal of earthly impurities, or earthly impurities are also known as gangue. So, removal of gangue is known as enrichment or concentration of ore. Okay. At that time, different techniques we are adopting depending upon the physical properties of ore and gangue particles. If the ore is light there, at that time we can use water there for cleaning that impurities from that ore. We can pass a current of water so that light ore will be trapped there, and other impurities will be going with the water. And depending if the impurities are heavier, that time also we can adopt another technique for separation of the separation of ore and gangue particle in that. So, if suppose any one ore or gangue particles have that magnetic property, at that time we can adopt the method of magnetic separation. So, different methods are there for the enrichment of the ore. Depending upon the nature of the ore or gangue particle, we can select these different techniques for the enrichment or concentration of the ore. So, that is the stage 1. Then further moving to the second stage, we have already seen that extraction of the metal. Extraction of metal. At that time, during the extraction of metal, we can see depending upon the reactivity of metals, we are adopting different techniques. So, we can see how do this metals of the bottom reactivity series or metals of the least reactives are separated from their ore. First we can take that category. Okay. Among the during that extraction of metals, first we will see metals of least reactivity. Metals of least reactivity, that in that such cases we have seen that copper is there, mercury is there, silver is there, and gold is there, isn't it? So, at that time these 4 metals we have seen there, and among this gold is seen in nature in free state. Gold is seen in free state, and the remaining 3 are existing in compound form. So, in this case we will see how do we separate copper and mercury from the ore. Okay. So, moving on to separation of extraction of copper. Copper is existing as nature as copper sulfide. Copper in nature is existing as copper sulfide. Okay. So, that is their ore. Ore of copper is copper sulfide, and that copper sulfide we are using the heating that copper sulfide in excess of oxygen. In excess of oxygen we are heating the copper sulfide. At that time what we are seeing, the copper sulfide is heated in presence of excess of oxygen. Sulfide will be converted into oxide. So, you will get copper oxide and sulfur dioxide. Sulfur dioxide is being a gas, it will be liberated out easily. It will be escaping out easily. So, when this copper sulfide is heated, for heating either we can write heat or we can use this symbol for heating, and during heating in excess of oxygen we are heating that copper sulfide. Copper sulfide is converted into copper oxide and sulfur dioxide will be produced while heating, and this equation is not balanced. We have to balance that equation. At that time, if you are balancing it, you will get this one 2. Okay, so while heating copper sulfide, you will, in a presence of excess of oxygen, you will get copper oxide. So initially we are taking the ore and heating in presence of excess of air. Okay, then that metal will be converted into, now from the sulfide form it will be converted into the oxide form. Okay, from the oxide form we can easily separate the metal. Okay, at that time this copper oxide is mixed with copper sulfide. We are heating both copper sulfide and copper oxide, both we are mixing there, and after that we are heating it. We are mixing, obtain copper oxide and copper sulfide. There you will get copper. Copper will be separated there, and the sulfur and oxygen will combine there to produce sulfur dioxide. So copper oxide is mixed with copper sulfide, that is self reduction is happening there, metal is reduced by self. So at that time you will be getting copper there. So in case of metals of least reactive, we are adopting the technique of self reduction there. There initially we are heating it in presence of excess of oxygen, so that sulfide forms will be converted into oxide form, and then from the oxide form by the self reduction processes we are getting this metal. So now the metal is separated there. Understood what is the second stage, extraction of the metal? I told that extraction of the metal is separation of the metal from its ore. So here the metal obtained will be, we are getting that metal separately from its compound. So initially we are taking the ore and we are purifying the ore by removing that earthly impurities which are known as gangue, and that process is known as enrichment of the ore or concentration of the ore. For that we are adopting different techniques, the gravity separation, then magnetic separation, simple hand picking method is the by using levitation method is the, froth flotation method is the, different techniques are there applied for the concentration of the ore. Once if the ore is concentrated, that means impurities are removed there, it will be taken to the next stage, that is extraction of the metal. During that extraction of the metals, depending upon the reactivity of the metals, we are adopting different techniques, different methods for the separation of the metal. So first of all we are seeing the metals of least reactive cases. So first we have taken the example of copper there. Okay, now we can see example of mercury there. If you are taking the mercury Hg, so this ore of mercury is cinnabar. Cinnabar is the ore of mercury, and which is in the sulfide form. Mercuric sulfide is known as cinnabar. So mercury in the sulfide form. So at that time what is happening to separate that, to extract the metal? First of all again we are heating that cinnabar or mercuric sulfide in presence of oxygen there. Excess of oxygen we are using the for heating that mercuric sulfide or cinnabar. So in excess of oxygen we are heating that mercuric sulfide. At that time it will be converted into mercuric oxide and sulfur dioxide. On heating that cinnabar in excess of oxygen, mercuric oxide and the sulfur dioxide will be produced there, and here we have to balance it, oxygen. So 2, sulfur is 2 here, so we have to make both sides equal. So there also 2, now oxygen is 6 here, now it is 4, so here also 2, mercury also equal. So at that time cinnabar is the ore of mercury which is in the sulfide form, heated in excess of oxygen, so that mercuric oxide will be getting there by removing that sulfur dioxide. Once mercury is converted into mercuric oxide, once if mercury is converted into mercuric oxide, if we are heating that mercuric oxide in the absence of oxygen, this we have to heat it, okay. In the absence of oxygen, if we are heating it, the metal will be reduced to, the metal oxide will be reduced to metal. So, there you will get mercury plus oxygen. Okay. So, when mercury is heated there, even in the absence of oxygen, metal will be reduced, metal oxide will be reduced to corresponding metal. So, in the case of least reactive metals, we are heating it first in presence of excess of oxygen, and then in the absence of air we are heating it. So, self reduction will be happening there, we will get a corresponding metal. Okay, this way we will be getting the metal. Copper there separated and here mercury separated. After separating these metals, we have to take that metal to the third stage, that is purification of the metals. The metals obtained in this processes may not be completely pure. Again, some other elements will be associated there in minute quantities. At that time, we have to remove that also during the third stage, that is purification process, or we will call that process as refining. We will see that later. Okay. So, these all about the extraction of the metal at the bottom of the reactivity series. So, for the separation of metal, there are three stages. First one is enrichment of the ore and the second one is extraction of the metal. Enrichment of the ore is to remove the earthly impurities or gangue present in the ore, and for that hand picking or gravity separation, levitation, froth flotation, different methods are adopted for that purification from the earthly impurities for the concentration of the ore. Then moving to the extraction of the metals, that depends upon the metal's reactivity. Depending upon the metal's reactivity, we are adopting different methods for the extraction. First, we are seeing the metals at the bottom of the reactivity series or least reactive metal. Some are seen in pure state in the earth crust, no need of adopting any technique for them. For them we need to purify only need to purify. But some other metals which are appearing as compound form, we have to take such metal compounds or ores, and then we have to adopt this method. Initially we are heating that. In case of copper and mercury, we are taking two examples here. In case of copper, we are heating that copper in presence of excess of oxygen, copper oxide will be produced there, and that on heating mixing with the copper sulphide, copper will be getting there. And then ore of mercury is known as cinnabar, which is mercuric sulphide, and that is heated in presence of excess of oxygen, we will get mercuric oxide, and that on heating we will get mercury. So, these are the extraction of metals at the bottom of the reactivity series. Thank you, children.